this one is RAM type BOB operation. You have the pipe RAM, so you have hydraulic pressure to give pressure to open the RAM or give pressure to close the POP. Each RAM is designed according to the manufacturer to have some gallons from hydraulic oil to close or open. So usually the hydraulic fluid is a closed loop or closed system. So when you try to close, you will open, you will get pass here to the closing chamber to fill with hydraulic oil to push the ram to close around the cold tubing. The other side here, there is opening chamber will be vent back to the reservoir tank to the accumulator bottle again charged. So this is closing system or closed loop. This one is sweep hole. Usually any sealing ram has a sweep hole like vent or drain hole. If you have any leakage for the primary shaft seal inside the ram, so it will start to vent gas or oil or hydraulic fluid, give you indication that there is internal leak inside the ram. You need to replace the leakage or fix the leakage and replace the primary shaft seal immediately. This one is the third or the tertiary well control barrier. In some manuals, it's called single ram or safety head or shield seal BOB. This one to increase the capability of shearing cold tubing, at the same time sealing the pressure or isolate the pressure of the well, especially used in high pressure and gas well beside the normal BOB or according to the policy for the company. This is tertiary well control barrier mounted above the Christmas tree direct without any connection below. Have or has separate control panel. We can operate from different panel to operate from also outside the location, because this one is last option. The same remote control panel which have the ESCD, it should have also capability to operate the safety head in case of any leakage below the safety head or between the safety head and the normal or quad BOB. You will apply the shear seal as last option, because you will cut the cold tubing drop in the well and then close all valve for Christmas tree. Before you operate, if you are on the bottom and you need to operate the safety head or shear seal, you need to picking up like 10 feet from the bottom and then start to operate the shear ram. Why? To give a chance for the cold tubing to drop inside the bottom for the well, and then so the Christmas tree valve will be free from any cold tubing through. This is the shearing and sealing in the same time for the safety head. Immediately position above the Christmas tree valves. This one is the shear seal actuator. This give you indications about this pin, give you indication about the closing and opening for the ram. This one is annular type BOB, sealed with tubing or without tubing, seal around any size versus size for pipe or bottom hole assembly, mainly used with long bottom hole assembly in the deployment system, optional, installed usually below the stripper assembly, has here piston, packing element and head. You give pressure from the accumulator or hydraulic pressure to push the piston above to squeeze the packing element to seal around the cold tubing or bottom hole assembly. You have another port here, closing, opening port, give pressure to retract the piston and open the packing element around the pipe. This one, the piston, packing element, opening port and closing port here. This one, the material or of the packing element we use in the annular preventer. You have 3 types for the rubber. Natural one is suitable with water-based fluid. There is 2 nitrile and neoprene. This one has additives against H2S and oil resistance. So this one suitable if you are working in oil or gas well. Nitrile is used in high temperature and neoprene is used in low temperature. This one is another option which is called flow T or pump and sub. Usually the pump and sub installed between the shear seal or below the BOP. Used for vent any pressure to take return from the well for circulation, allow for bleeding of well fluid and the gases, assist in the introduction of the fluid or take return from the well during circulation instead of using the kill line. The kill line only for emergency or killing operation. This valve or pump and sub must have 2 isolation valve from outside. Normally one is manual, the first one near to the body for the flow T, and the external one usually is hydraulic operated valve, or in some cases both is 2 manual valve. So you have 2 isolation or double barrier. This one, in some cases, you have here the 2 isolation valve above the Christmas tree. In some cases, we use isolation valve above the or 2-way valve above the Christmas tree. Did you use this one before?
We use floaty.
Yeah, floaty is different from this one. Above the Christmas tree, you know, all stacks here for BOB must be pressure test from below. That means all pressure will be against the crown valve for the Christmas tree, right? But we said yesterday that all Christmas tree valve holding pressure from below, and you now apply pressure, it's holding pressure from the top. That's why instead of holding pressure from the top, you nibble up another valve which is called 2 isolation valve. The 2 isolation valve hold the pressure from top and from bottom. So all pressure for your BOB stack, it will be against this closed valve to protect your crown valve of the Christmas tree from failure. Or in some cases, you can nibble up or install double crown valve, another crown valve above the primary one. This valve will be used for pressure test only. After that, after you finish the job, will be removed from its place. By this case, you protect your Christmas tree valves to hold any pressure from the top. You get my point?
Yeah.
Okay. This one, medium pressure control equipment stack here, according to the policy in some company, from 0 to 3,500 PSI. This is the rigging up recommendation. Gooseneck injector head, stripper assembly, flow T, quad BOB number 5, shear seal, then Christmas tree number 7. This is for low pressure. high pressure rigging up from 3,500 psi to 7,000 psi. It should be flange connection, gooseneck injector head. Then you have dual stripper, which is used in high pressure and corrosive environment, which is choice. Annular BOB optional. Quad BOB here. Flange or riser. Flow cross double isolation valve. Then another quad BOB, extra precaution. Then shear seal below, above the Christmas tree. This is extra precaution in case you have high pressure wells. This is some recommendation according to the strategy or policy in some companies. Again, just to remind, this is the primary barrier, the stripper assembly. Secondary barrier is the quad or compi BOB. Tertiary one or last option is the shear seal above the Christmas tree. How we can pressure test the pressure control equipment? Before expose any piece for pressure control equipment or the BOB to the well pressure, we need to pressure test and check the integrity for the system or the rigging up. So now the primary barrier is the stripper, secondary barrier is the BOB, tertiary barrier is the shear seal. All these elements seal the pressure in the annulus area around the coil tubing. So what is the primary barrier and secondary barrier and tertiary barrier to prevent the pressure to go inside the coil tubing? What is the internal barrier for the coil tubing?
The check valves the MHA.
The check valve in the bottom hole assembly is the primary barrier. Prevent the fluid or the pressure to pass up to the surface in case you have any broken pipe or leak at the surface. This is the primary barrier. It will be the check valve, and usually the check valve is tested and dual check valve, two check valve together. What is the secondary barrier in this case? Internal.
Once again.
What is the secondary barrier? You need to have three barriers, internal and external barrier. The internal barrier, the primary one, is the check valve. If you have failure in the check valve and you have leak at the surface, so what's your secondary barrier here?
Secondary barrier is the reel manifold.
No, on this one. The secondary barrier will be the shear ram in the quad BOB. If your dual check valve is not holding the pressure and you have escape for high pressure at the surface, you will cut the coil tubing with the shear ram in the quad BOB. This one, it will be the secondary barrier. The tertiary one, it will be the shear seal above the wellhead or the Christmas tree. So the external barrier, first stripper, secondary is the POB, tertiary is the shear seal. Internal barrier, it will be coil tubing check valve in the bottom hole assembly. Secondary one, if you have failure in the check valve and you have a leak at the surface, so you will cut the coil tubing with shear ram in the quad BOB. Tertiary one, it will be also the shear seal. In some operation, you need to do job like reverse circulation job. In this case, you remove the check valve from the bottom hole assembly. So you don't have any primary barrier inside the coil tubing. So what is the primary barrier in this case? If you have leak at the surface for any reason. Now the check valve is out, so you lose the primary barrier, the check valve. Because the reverse out, you need to remove the check valve from the coil tubing, so you'll be able to reverse out circulation.
The secondary will be the primary, the shear.
Yeah, the secondary barrier, it will be the primary barrier here, which is the shear ram in the quad BOB. So the quad BOB will act as here as primary barrier. And the secondary barrier will be the tertiary one in normal condition. The secondary will be the shear seal. And in some recommendation, they advise to install double shear seal to be the tertiary barrier in some cases. Okay. So this one, we need to pressure test pressure control equipment. We need to test all the stack, including all connection and the flange. And also need to test the internal barriers, which is the dual check valve, pressure test bottom hole assembly. All pressure tests should be applied from bottom, and you have two pressure tests to apply. One is low and another one is high pressure. The low pressure test, usually it is around from 200 up to 300 or 250 psi. Hold for minimum 5 minutes or 10 minutes on chart. Then you will go up to the high pressure test. Pressure test should be gradually in stages or in steps and should be recorded in graph or chart. About the pressure test or high pressure test, how much pressure test you apply on the coil tubing BOB or rams and the high pressure test?
Well, that depends on the job and the limitation of wellhead, Christmas tree, the equipment you are using, or
If
the
you-
job itself.
If you have Christmas tree 3000 psi and your pressure control equipment is 10K, so what's your maximum pressure in this case?
Would be 3,000 with the Christmas tree, or any a little bit under 3,000.
Little bit like 80% from the pressure for the Christmas tree. So this is the first option. He will go to the maximum pressure for pressure control equipment or the wellhead, which is less. This is the first recommendation in some company. There is another recommendation according to the API talking about if you have wellhead 500 psi or 1000 psi, do you need first time to go to 3000 psi for pressure test? In some policy or in some recommendation, they recommend on-site pressure test to be 1.2 to 1.3 from the maximum wellhead pressure expected during the job, or 10% above the maximum wellhead pressure expected during the operation. For example, if you have wellhead 1000 psi, you can go like 1200 or 1300 psi. You don't need to go each pressure test up to 3000 psi, which is the wellhead pressure for Christmas tree. Why we do like this? In some recommendation, they said more pressure on the body for the BOB, that means more fatigue for the material of the BOB. That's why they apply this recommendation. But some policy for companies, for some company, they restrict to do pressure test on the full pressure test, the maximum pressure you can go regarding or without taking in account the wellhead pressure, how much before the job. So you have 3 recommendations: full pressure test with high pressure of pressure control equipment or wellhead, or 1.2 to 1.3 expected maximum pressure, or 10% above the wellhead pressure. This is for high pressure test. You apply this recommendation?
No, so far no.
Okay, this one recommendation, it is only on-site pressure test. but off-site or in the workshop, you need to go 100% for pressure control equipment for the POB or lubricators. Usually we do the pressure test with water, clean water, not with mud or any brine or nitrogen. In some cases, as we said, to prevent forming of the hydrates or ice, you do the pressure test with mixture between water and glycol, 50 by 50 on the volume or 60% by 40 of the volume. Also, we don't need to pressure test any coil tubing with nitrogen because the nitrogen will start to make erosion for the pipe and make reduction in the life for the coil tube. Let's go on steps for the procedure for the pressure testing the VOB. First, after nipple up the shear seal, the tertiary barrier above the wellhead or Christmas tree. This one is external source pump. This one is the reel for the coil. Sure, from beginning will flush the coil tubing and drop launch ball and get at the surface. After that, we'll start to pressure test. So we'll start to pressure test from below the shear seal, from the wing valve of the Christmas tree. You'll apply the pressure at the same time to the surface line, or the surface line low and high pressure test till the inlet for the reel. This is the first test, low and high pressure testing shear seal ram. After that, second pressure test, you need to pressure test the reel with test cap. You can install test cap at the end for the coil tubing, and you start to pressure test all the coil tubing in the reel to the end. This is another pressure test. Third one, after you nipple up the VOB, you will start to pressure test first the blind ram and lubricator section. So you will start from wing valve of the Christmas tree, apply the pressure, which is the yellow color here. You close the blind ram, then you apply pressure from below, and after including lubricators, after that you bleed pressure test. Here you need to pressure test the pipe ram and for the stripper assembly first. So you will apply pressure test through the reel. All pressure tests will be through the reel for the coil tubing, except the blind ram and shear seal ram. It will be from the wing valve of the Christmas tree. Here you will apply pressure test. The pressure test will go through this area. You close here shear seal, so it will be pressure up around the stripper assembly where the coil tubing inside the well, to check there is leakage or not around the stripper assembly. Pressure test here, last pressure test for the pipe ram and the check valve also. You will apply the pressure test through the coil tubing reel. You close the pipe ram. Again is the shear seal from below. So at this moment, the pipe ram is tested from below for low and high pressure test. Now, if I need to pressure test the check valve, what I should do? What I should do to pressure test the check valve? Inflow test for sure.
Bleed of the pressure in the reel.
Yeah, I will start to bleed pressure above the check valve. So I will start to bleed off the pressure inside the reel to certain value or to 0, but make sure you will not exceed the collapse for the coil tubing. And then there is pressure from below the check valve in the well. So at this moment, you start to monitoring the gauge for the pump or inside the coil tubing. If there is no build up at the gate, that means the check valve is holding pressure. If there is build up at the surface, that means the check valve is passing pressure or fluid. By this way, you do the inflow test for check valve. Now, this is the coil tubing. What is the standard coil tubing bottom hole assembly we can use during operation? Bottom hole configuration must be in sequence like this. First, the coil tubing. There is connector between the coil and bottom hole assembly to have connection to connect the bottom hole assembly. This connector can be external or internal connection based on the design and the job type, and also based on the minimum ID you can passing through. Number 3 in sequence, 2 or dual check valve. 2 check valve, 1 backup for the another. Number 4 is release sub. Number 5 is circulation sub. Then you have a special tool. The special tool here can be downhole motor or jet nozzle or bull nose or bridge plug based on the job type. But till number 5 should be in sequence like this. The release sub you can release from if you have stuck inside the bottom hole assembly of coil tubing. So you drop ball, then you circulate behind till it's latch in its place. Then you have pressure up to release or break shear bend. Then you pulling with the rest of the assembly and coil tubing out. Leave inside the well bore the stuck bottom hole assembly. Here is circulation sub. This also acting with, you have port, you drop another pole also, smaller than the top ball. The pole will be landed in its place, then you apply pressure to start to break or rupture disc or open port. The port, when it's open, it will be permanent inside the bottom hole assembly. That's why the circulation sub cannot be above the check valve. In this case, if you open the circulation sub, that check valve will be useless as a barrier. At the bottom here, there is a special tool. It can be motor for rotating or jet nozzle for washing or bull nose or logging tool or perforation gun based on the job you need to perform. This is different type for connectors. For coil tubing, you have dimple connector here. This is the dimple tool. You have set screw here to connect the coil tubing with the connector. And there is O-ring here for sealing. This one can be external or internal connector. This is another type, which is called gravel connector. This is the most common type. You have gravel like the gravel for the fishing to connect also with set screw the coil tubing with the bottom hole assembly. This other type also is called roll-on connector, internal connector. It's not external. And this one you have O-ring here. You have crimping tool to make this type for connection. This one roll-on connector used in low torque on light job like clean out fine sand or something. No rotation required. You will not go with motors or no need more tensile strength in the operation. Which type you used for connectors?
You have internal, external dimple, internal dimple.
External and internal dimple. Okay.
Yeah.
Use this type roll-on connector.
Roll on a special case only.
Which cases? Like what?
Like if you have restriction and then when we do Y tool jobs.
You do Y tool job?
Yeah.
For ECP, you mean?
For the ESP, yes.
Okay,
When we do logging,
okay. And this type, Gravel one.
we used to use before, now no more grapple. We're not using grapple, only dimples.
Okay. This one is a special for line coil tubing or coil job. You have a special electric connector to connect the power from the surface, give signal through the line passing through the coil tubing till to make connection with the downhole assembly. This one is the check valve, dual check valve, different type. It can be ball one, like number one, or it can be dart. It can be flubber number three, which is the most common type used during the operation. This one is the best because gave ability to drop any pole, launching pole, to drop on circulation behind. It will be open, passing the pole to do any job for circulating sub or release sub below. This one number four is a spring return check valve. And number five, this one is pressure retaining the check valve. Apply with the pressure, similar to the spring type. This tool is the release sub. It can be ball operated. You drop ball in the seat here. Then you have pressure. Then you pressure up. Then you straight up to disconnect this pin. So it will disconnect to two parts. Then you pulling out with the wrist out from the well. Number two, this one pressure activated release sub, similar to the pole, but pressure differential in the coil tubing can activate the sub. The pressure from inside and outside after you drop the pole. Number three, this one is tension activated release sub. That means only with tension you can release the or break this pin on certain value. This one is not common type because it can be accidentally released with overball during operation. It can release this tool by mistake. So this one is not common type. We need overball from surface to shear, screw, and release sub. This is some special tool in the bottom hole assembly. It can be ball nose or port for circulation. Number two, this one mole show and angle jet to jet in some certain area. And this one number four is drilling motor for drilling application or clean out plugs or consolidated sand. Drilling bits for CT drilling application, blind box, this for fishing operation, casing cutter, under reamer to enlarge the hole inside. This one is called CT tractor. Did you use this one before, this tool?
No, we didn't run.
This type can be used as a part of bottom hole assembly if you are need to push the coil tubing inside horizontal section or highly deviated well to the maximum. So you have here like roller. This roller is retract. When you need to operate, you will start to pump through the coil tubing. At certain differential pressure, this roller will be out from its place or grip in the wall for the pipe or the casing. So it will, by pumping, continue pumping through the coil tubing, it will start to push the coil tubing in horizontal section to the maximum depth. This one I used before in Saudi Aramco in one exploration well. we try to do stimulation job and logging job inside the multilateral tool. So we activate this tractor and try to push the coil tubing to the maximum depths we can record the logging at. Another special tool is called CT-MLT. This is in case you have well with multilateral well. You have many lateral inside the well bore, and you need to go inside selected one lateral. So this MLT give you chance with differential pressure also working to perform well intervention job or acidizing job or logging inside multilateral well. Work also with differential pressure and pumping through the coil tubing. This one is to check or search about the degree or azimuth for the multilateral tool to select which lateral you need to go inside. Did you work with this tower before? Coil tubing, CT coil tubing tower?
No, I didn't.
This one, in case you have long bottom hole assembly, long lubricator sections, so we install this tower, so you don't need to have crane in the operation. Just you put this or install the injector above here on the jacking system. This one is working with hydraulic pressure. It can be rotate little bit or being up and down with the jacking system, hydraulic system. You have this bases, this phase, and then you start to build each section together, and the lubricator will be here through the hole. After you need to disconnect again, this you will acting the jack, so you disconnect from the top, pulling from here, and then start to getting the assembly from out from the lubricator to change to another bottom hole assembly. Also, I use this one in Saudi Aramco in one well, exploration well, because this time we have accident of the crane. The crane operator at that time slack some weight while hang this section, and accidentally we have leak in the Christmas tree during stimulation job, a live well. At that moment, we secure the well and we order this coil tubing tower for safe operation. We don't need to have crane in the location. So it is so safe, cost-effective, rigless, long assembly operation, hydraulic jacking system. After that, we will talk more about how the coil tubing can affect and what is the damage source or fatigue or failure for coil tubing during the operation. What are the causes can lead the coil tubing to fail? Usually the coil tubing, when it's come to the location, you need to know the percentage for the life for the coil tubing. How many runs, and after how many percentage consumed, you need to discharge the coil tubing or you take it out from the surface. What's the policy about the percentage for coil tubing?
Sorry, once again.
You have percentage for the coil tubing, the remaining life for the coil tubing, right? According to each job you perform. This one can be calculated from the system or the computer system, right? So at what percentage, according to the policy for your company, you reject the coil tubing out of the service?
Coil life will go to 100%. Generally, 80% we remove mostly.
Yeah, 80%. And most policy for companies it is 80%. When you reach to 80% consumption for the cold tubing life, it will be reject and get out from the steps. 80% normal. Your software is called CoilCAD, right?
Yes.
Okay. There is some factor effect on the cold tubing life. Some factors here is internal pressure while cycling, while running and pulling, internal pressure inside. Spooling itself can affect on the pipe because of stress, storage and surface condition, atmospheric condition. That's why if you need to store cold tubing, you need to apply grease and cover the reel. Rear radius, that's why you need to select proper radius for the reel. Large radius give lower stress for the cold tubing. The gooseneck roller, numbers for rollers on the gooseneck, more roller give you more flexibility while cold tubing passing on the maximum bending on the gooseneck. Rig up alignment in the center or not. Corrosive fluid, if you are going to pump acid stimulation, you need to add some corrosion inhibitor because the corrosion or the acid will react with the cold tubing material. It will shorten the time or the life for the cold tubing. Axial load, the tensile stress on the cold tubing due to elongation, make elongation or fatigue with the time. Traction pressure applied on the cold tubing also, if you apply more pressure, it is one of the source for damage or fatigue for the coil tubing. Here, this is the bending stress or cycling fatigue for the coil tubing while bending stress. Here, the coil tubing is bend on the reel, then you start to straight while running on hole, then bend again, number 2, maximum bending over the gooseneck, then straight again while running inside the well. While pulling out, the reverse will happen, bend, another bend, then straight, then bend again. This is called bending cycle. The bending cycle has 3 places to happen while running for round trip and pulling. Each place there is 2 events, 1 6 here, 2 5 and 3 and 4. So normally we have 3 bending cycle with 6 bending events while round trip the coil tubing during the operation, especially if you have pressure inside the coil tubing also. This one is definition is called ovality for the coil tubing. What is mean of ovality for coil tubing? Any answer?
Sorry, one more time.
What is the meaning of ovality for coil tubing?
Ovality is the shape, means whether along.
Yeah, the coil tubing is come out of round. It's take the oval shape. Okay, this is the meaning for ovality for coil tubing. Usually, the coil tubing while manufacturing is not come 100% in round shape. There is little bit deformation due to the manufacturing and sizing for the coil tubing. So if you need to measure the ovality for the coil tubing while operation, especially if you have high pressure inside, during the inspection, you can read percentage for ovality by this equation. The maximum OD for the oval shape minus the minimum OD, this area, divided by the design OD for the coil tubing, like 3.5. So you measure the maximum and the minimum minus by the designed or the standard OD for the cold tube. What is the acceptable limit for the ovality of the cold tube? The acceptable limit for the ovality for coil tubing is 5%. The change in the rounding for the coil itself. If it is more than 5%, it will be rejected for operation. Why the ovality can affect the operation for the coil tubing? How can the ovality affect the operation for the coil tubing? If you have oval coil tubing pipe, how this can affect during the operation?
Because of the ovality, there will be a lot of slippage of the pipe.
Okay, first thing about the well control, which is the main. If you are closing pipe ram in oval pipe, it may not secure the well or seal the coil tubing, because now the coil tubing is in big size than the required the pipe ram to seal around. This is the first effect in the well control operation. Second thing, when you're passing the oval pipe through the gooseneck, it can hang over the gooseneck and stripper assembly. It may be stuck in the stripper assembly while pulling or running out from the hole. That's why the acceptable limit here for most for company or policy, it is assumed to have 5% ovality only. More than this one, it will be rejected for operation. This is another source for coil tubing damage also. When you pump abrasive fluid like cement or sand-laden fluid contains sand, so it will cause wear for the coil tubing from inside or from outside, which will result in shorten the working life for the coil tubing. Another source also, can you make mute please? Okay, thank you. Another source for coil tubing also is the tension or the stress. If you're hanging weight of the coil tubing for a long time, you have overpull or tension. So the coil tubing now start to have or has fatigue with the time, and the fatigue will affect on the collapse resistance and first resistance for the coil tubing. Excessive tension contributes greatly to a decrease in the collapse resistance. And so also when you have oval pipe, the first effect also it will be the thickness for the coil tubing become thin, so it will be also affected on the collapse. The collapse will be resistant will be less over the operation. There is also a concept called buckling for the coil tubing. Here, there is two types for the buckling can happen for the coil tubing. When you start to push force, apply to push the coil tubing string, especially in deviated or horizontal well. So you have two types for buckling. First one is sinusoidal buckling, like the S shape. When you're pushing the coil tubing more, you have slack weight on the coil tubing. So you will convert to another type for buckling, which is helical buckling. At the helical buckling, when you start to put more weight, you will reach to lock up. So you cannot going more down. That's why in this case, you need to have roller or tractor for the coil tubing, which help to push the coil tubing without need to put weight on the coil tubing and cause damage or fatigue due to the buckling effect. The buckling effect here causing permanent damage or failure for the coil tubing, especially if you have long buckled section for coil tubing in the horizontal well. All this failure or fatigue can be checked after you make full inspection, after you finish each job. Another source for damage or fatigue for coil tubing is the injector. If you are going to grip many times the coil tubing under pressure and you exceed the pressure for hydraulic, you will have some mark here. This mark comes from injector chain from outside. This can make wear or scratching on the coil tubing from outside. This mark also for slip ram for the coil tubing. When you start to operate the slip, this slip mark, that's why when you activate the slip ram, after you open again, you need to pull out certain lengths out to visually check the coil tubing outer diameter or check the surface or the body of the coil tubing from outside. Because this all scratch with the time will affect on the collapse and the strength of the coil tubing, make fatigue or fitting or hole on the coil tubing and damage. This one is crack, can happen. Different type for crack can happen like this or angle or longitudinal crack. This crack, first when the coil tubing is filled, we will start with spin hole or fitting. Then with the time it will enlarge and start to have the crack in the coil tubing. The pitting here is the first thing you can find in the coil tubing. This one you cannot notice by eyes, so you can check by the process for checking the coil tubing after each job for inspection. This can be happen due to corrosion, internal or external pitting could happen when there is contact between the coil tubing and corrosive treatment fluid like acid job, or it can happen with atmospheric corrosion. That's why you need to apply grease when you need to store the coil tubing after the job, or it can be combination of both. Internal pitting is directly related to contact with improperly inhibited treatment fluid. That's why you need to add small percentage of corrosion inhibitor during the job design. So it starts with pitting, then with small hole, then with crack or big hole. This another source also is called abrasion. This one is coming from, it can be scratch or tint due to contact of the coil tubing with the high inclination well, or come from buckling. So this one here, scratch can happen a result of contact with sharp edge. Like when you are running inside the well, you have scratch, not center the coil tubing inside the well bore. So you have contact between the coil tubing and the wall for the pipe, or inside the PUB equipment, or it can be happen due to coil tubing handling and spooling equipment. This one is also can cause damage or effect in the wall thickness for the coil tubing and affect on the performance or cause failure or fatigue to the coil tubing with the time. This one is type of the how to inspect the coil tubing. After each job, we need to pass all the reel through the magnetic flux leakage system. This one system we use to identify any drop in the metal thickness in the coil tubing. So when the magnetic source is passing around the coil tubing, if you have any little pitting or damage, it can be detected by leakage of the magnetic field from the steel. So it will have 30, 100, 360 degree cover for the pipe, including outer diameter, inner diameter, or thickness. It can detect any corrosion, pitting, or any defect in the coil tubing, give you the result. It can continue or it can reject from the steps. Okay, gentlemen. Ms. Hajar, okay?
Yes.
Yeah.
Do you apply this type for system in your operation?
We still don't have, we do have in Schlumberger coil scan equipment. It's for the same inspection, but currently we use third party to do the inspections.
Yeah, it can be third party, yeah. You have
Yeah,
contract
we-
with third party, yeah.
We use third party companies, but we do have this technology in Schlumberger, but in Kuwait we're not using it now.
Okay, so what is the type for inspection you do after each job?
This is not after, we don't do magnetic flux leakage system after each job. We do it like after 10 jobs or something like that based on our contract with the client.
Okay.
Hmm.
So what is the type for inspection you do after each job? Just a pressure test?
Every job we run
Yes.
UTIM, like integrity monitor to know the ovality of the pipe. So, but for the magnetic, as Hajar said, we do third party.
Okay, so you do some inspection, but it's not full inspection like this system.
This is only, we'll check the ovality only. From our side, we'll see that we have two monitors, length monitor and ovality monitor.
Okay.
And the third one is like after a couple of jobs, we do the third party scan.
Also,
Like this
the
one.
job, we do the pipe management, adding the modifying factors in coil cap system.
Okay, so the same time you mean during the job you have the system to checking coil tubing or what?
We have a
No, after the job.
we have a UTIM. It is called universal tubing integrity monitor, which will measure the ovality.
Okay.
And
Oh.
after the job, we add the modifying factors to our system to check the life.
Okay, yeah, based on the job parameters.
Yeah.
Okay, to give you what is the remaining percentage or consumption for the coil tubing after this job.
To give us the effect of, for example, H2S or acids after the job.
Okay, yeah. All right. So this full inspection we can do according to the agreement with the client after like numbers for runs.
Yes.
Okay, got it. Yeah, thank you. All right. Any question to this point?